What is up, Jaguar students? It's your friendly neighborhood math teacher, Mr. Allred, and we're back with Unit 8, mini lesson number 3. Today we're going to talk about composite and inscribed figures. These are complex two-dimensional shapes where one is inside of the other or one is next to the other. And we're going to find the area of either the shaded region that is in between them, or we're going to find the area of their composite area together. And you should be able to explain how to find the area of composite and inscribed figures by the end of this short little video. Okay, we're going to go ahead and get started with the notes. And what you'll see, if you just flip that paper over to the front and the back and you kind of look at some of the shapes on there, you might think they're kind of scary. Do you think they're kind of scary? I think they look a little bit scary too. Okay, but the truth is I'm going to give you 3 quick and easy steps for finding the area of these really scary figures. Okay, and just remember that anytime you have a question, you can always pause the video and talk to a partner. You could always pause the video and write a Post-it note and put it on my parking lot back in the corner. And you can try to keep that question in mind and ask me when you come to my station. But the first thing you're going to want to do is you're going to want to figure out which shapes you have sitting there. If it's a square and a circle or a square and a triangle, you're going to want to figure out what kind of shapes you have. You're going to find the area of both of those shapes. You can use your formulas to do that. The formulas that we've talked about so far in Unit 8 will be very, very helpful for you as you're trying to find the area of these shapes. You might have a trapezoid or a triangle or a square or a circle, and you'll need to use that formula. And then we're going to add or subtract the areas of the shapes depending on the problem. We might add or subtract the areas of the shapes. I'm going to do a couple math problems here with you today, okay? And I'm really just going to leave you kind of to be after that, because I think the only way to get good at this is to practice it. Octavio Paz, a Mexican poet from the early 1700s, once said, "Deserve your dream." And if you want to be good at these composite figures, that's great. You got to earn it. So let's go out here and earn it, okay? Well, look at this first problem. I see 2 squares, okay? So I put 2 squares, the big old exclamation point there. I see a big square. The big square has an area of 8 by 8, 64 inches squared. That's this big square right yonder that I'm highlighting right here with my marker. This big old square right here. And then there's a smaller square. It's just 4 by 4. It has an area of 16 inches squared, and it's hanging out right here. Okay. I think it's great to know all that information. It really is. But the truth is, what had happened was somebody took that big old square, the 64-inch squared one, and they plopped it down on the table. And then they took their little scissors and they cut out a big old, or a little old square in the middle of it, a 16-inch square in the middle of it. If we wanted to figure out the area of the shaded region, we need to subtract 16 from 64, and that'll tell us that the area of the shaded region is 48 inches squared. It's the truth. It's the gospel truth. The area of that shaded square is 48 inches squared. So all I did is I found both the areas of the big square and the small square, and I subtracted the small one from the big one to find the area of the shaded region. Okay. The truth is they only get more exciting from there. They really do. This is really just going to be a life-changing moment for you. And this next math problem, I see a rectangle and I see a semicircle. A semicircle is a big old word for just a half a circle. So we're going to find its area by using the same formula we use for any circle. We're just going to divide it by 2 at the end because it's a semicircle. If I want to find the area of that rectangle, I'm going to do 13 times 9. I'm going to do length times width, base times height. I get 117 meters squared. When I do 13 times 9, I get 117 meters squared. The area of that semicircle, good people, it has a radius. We're going to do pi times the radius squared and divide by 2. This 7 meters right here, this is the whole distance across the circle. That is the diameter of that circle. If I want to find its radius, I need to divide 7 by 2. And that is why in my formula here, I've used 3.5, which is about half of 7. And I did pi times 3.5 squared. That would tell me the area of a whole circle that had the same radius. You need to keep in mind that you don't have that whole circle. So what I did is I took that and I divided it by 2, right, just like that. And I got about 19.2, that's what I'm going to call it, 19.2 meters squared for the semicircle. Okay, If you're not still with me, pause it, right, and read through what I did. I had a rectangle, I found its area. I had a half a circle, and I found the area of what a whole circle would be like, and then divided it by 2. Okay? If I want to find the area of that shaded region, I have the whole rectangle, but somebody took a big old bite right off the top right corner of it. So I'm going to take 19.2 and subtract it from 117. The area of the shaded region there is about 97.8 meters squared. Okay, so I've done 2 problems here for you. You've got this one. This is a composite shape. That just means that there's 2 shapes, 2 or more shapes together. I would maybe spell that word correctly. That's what I would do. I would maybe write that down somewhere on that math problem so that when you go back and look at it later, you can understand it. All right, we're going to flip over to the back, and I'm going to look at this guy. This is my favorite math problem because I call it, as you look at it, you see a square and a circle. I have a funky word for it. I call it a squircle. That's right. This is the squircle. It's a square and a circle inside a square. That's right. It's a squircle. Okay. If I want to find the area of that square, the big old thing that the circle is inside of, I can do 20 times 20. 20 times 20 is about 400 inches squared. That's the area of the square. Okay. If I want to find the area of the circle, the 20 inches goes all the way across it. That would be its diameter. But its radius would be about half of that. It would be 10 inches. So I'm going to take my formula, pi times the radius squared, and do pi times 10 squared. And you have your little calculator. You're plugging away. You're pushing some little buttons. You probably pushed about a couple buttons, right? And you probably got about 314.2, round to the nearest 10th inches squared for that circle. If I want to find the area of the squircle, the shaded region outside the circle but inside the square, I need to take my 2 areas and subtract them. Take 400 and subtract 314.2, and you'll end up with about 85.8 inches squared there for the area of the shaded region. Okay, so what I've done is I've done about 3 out of 8 problems there for you. You got about 5 left. You can do some of those right now. You can do some of those when you come to my station. But I ask, as always, that you stay classy, right, and try not to be trashy, because of all my students that I've ever taught, you are one of them. Have a great day. Goodbye.